Secure Mailboxes is an asynchronous messaging platform akin to email. Interestingly, messages sent on the platform are encrypted end-to-end via asymmetric public key encryption. Here's a quick demo to show you what it's like.
Hey, I'm Andrew Bespaly, and I worked on the implementation of the retrieve endpoint for the API, and I also created documentation for the API using Swagger.
Hi, I'm Cameron Pyne, and I set up continuous integration and delivery using Travis, as well as working on using Docker Compose to build and run the API.
I'm Dajun. I predominantly worked on building and integrating command line functionality with UPG and Python UPG library. Also implemented unit and integration testing for the command line.
And I'm Thomas Honnell, and I worked on the implementation of the send endpoint for the API. I also did the API testing.
Hi, I'm Nicholai Venetucci, and I worked on implementing or integrating the CLI with the API, in particular making requests from our CLI to access our API endpoints. I also worked on CLI testing as well as created scripts to demo scalability and performance.
I'm Joseph Starr. I implemented our register endpoint for our API used to register a new mailbox so a user can receive or send messages, or a new user can. I also implemented some refactorization to our user experience just for a cleaner output for the user so it's not as busy, as well as general functional testing for our front and back end code.
And I'm Sam Gomena. I was the team lead, and due to that, I primarily focused on organizing, orchestrating, and just generally helping out the team where need be.
We used a basic client-server architecture. Both the API and CLI are built with Python. The API leverages the Flask web framework to provide a REST API and is backed by a Postgres database. Additionally, the API supports local and cloud deployments via Docker and Docker Compose. The Docker Compose cluster uses 3 containers, one with Nginx to act as TLS termination and reverse proxy to the API container to handle the business logic, and a Postgres database container for storing the encrypted messages. The CLI leverages Click, a command line parsing library, and requests an HTTP request library, as well as GPG for encrypting messages.
The Secure Mailbox API is a fully RESTful API. It is written in Python and uses Flask as its framework. The API provides the ability to create mailboxes, send messages to another mailbox, and retrieve messages from a mailbox. There's full documentation hosted using Swagger. It supports cross-origin requests, and the service is fully containerized. Here's a little walkthrough of the 3 endpoints we created for the API.
The register endpoint for the API is used to create a new mailbox. Passing in a fingerprint as a request, the endpoint checks if the fingerprint is valid and that it does not exist in the schema already. Then creates a new mailbox with a given fingerprint and automatically fills in relevant information regarding the mailbox. What is returned to the user is the success rate as well as any relevant error messages.
The send API endpoint is used to send a message from one user to another. The request arguments must have a fingerprint that represents who is receiving this message, a sender fingerprint for the person sending the message, and the message itself. After checking that both fingerprints provided are from valid mailboxes that have already been registered, message entry will be created and committed on the message schema. What will be returned to the user is a success state followed by an error message.
The API's retrieve endpoint is used to retrieve messages for a user. Given a user fingerprint as a request, the mailbox schema is searched for a matching fingerprint in order to find the corresponding mailbox ID. The mailbox ID is then used to search the message schema for all messages that correspond to that mailbox ID. If an additional sender fingerprint is found in the request, the search will narrow the results to only the messages that have been sent from that sender. What is returned to the user is its success state, an error message, a count of all the retrieved messages, and the data in the form of a list with all the messages, each with their sender's fingerprint and the date they were created.
The command line application allows a user to create and manage keys as well as interact with Security Mailboxes API. The key is created with related user information, and all public and private key can be listed, imported, and exported. The application accepts a fingerprint to create a new security mailbox if the fingerprint not exist. Also, the application check and receive the valued fingerprint and then decrypt the message and send it to the associated mailbox. The application also retrieves the message from the mailbox that associates with the given fingerprint. It optionally receives the sender's fingerprint to filter messages that come from the target senders, and then decrypt and print them.
For our Capstone development process, we utilized GitHub for basically everything. GitHub allowed us to each independently create branches, PRs for implementing new features, bug fixes, and test the PRs functionally and do code reviews. This was done also using the Agile methodology. We had our requirements met the first week, so we were able to get right on that, create different stories for each of our development team, each person in our development team, and as well as each person could review and comment on PRs and test everything.
As with any software development project, the team faced a handful of challenges. While these weren't necessarily specific to our project, we felt it would be good to highlight them in the hopes that future Capstoners or anybody else in a similar position could hopefully benefit from our shortcomings. And not surprisingly, working on a team obviously is not easy, especially for a team who has not previously done so. One of the biggest problems, not necessarily problems, but issues we faced was making decisions. We strongly felt that all decisions should include input from the group. However, at the end of the day, a decision does need to be made to move forward. One way we improved this was communication. Obviously, communication can always be improved, but communicating early and often, especially with respect to decisions being made that affect other members of the team, communicating openly and efficiently helps greatly reduce stress on other members of the team. And as aforementioned, the team used Git as well as GitHub for our version control and version control management software, respectively. There's kind of an unspoken rule that students just kind of understand Git or version control in general. We realize this with respect to our feature branch development paradigm, where we had the whole team committing to certain branches, opening pull requests, and a lot of those pull requests were sitting around for an extended period of time. And that was because people didn't know how to share their comments, questions, concerns with respect to the code in a pull request effectively. There's obviously no class for how to learn this, but it was definitely a challenge that we had to overcome. And again, not surprisingly, working with new languages, frameworks, libraries, we used Python, and a majority of the team had never worked with Python. It can be a daunting challenge to work in that environment, especially when you don't have peers to reach out to. And again, unsurprisingly, bootstrapping a project, the majority, actually everyone on the team was using a different operating system, and certain technologies that worked on one team member's device just didn't work on another team member's device. Had we done a little more due diligence in selecting the technologies we used up front, we could have prevented a lot of pain from the get-go. While this is the end of the Capstone project, we hope it's not the end of the project. The team had originally planned to implement a web-based client of the service. This obviously didn't happen, but we put in a significant amount of work into documenting the Secure Mailboxes API, as well as providing the command line client as a possible example that we think could provide a motivated third party to then easily implement a web-based client. Additionally, our project sponsor has started work on a sister project to ours, and he plans to integrate its feature sets into ours later this year. So potential work could stem from that. The team has continued interests in the success of the project, obviously. This has been an incredible learning experience for all of us, and as such, we have a vested interest in maintaining the project for the foreseeable future, not only as a learning tool and reference for us, but the open source community at large. And some closing remarks. The team would like to extend a formal thank you to Alan Anderson Pretty, our project sponsor, for submitting the project to the Capstone program and working with the team throughout the entire course of the project. To Bruce Irvine, our Capstone professor and mentor, for not only being available through everything, but also for playing a part in directly supporting the team leads as well as the team members. And to everyone else behind the scenes, completing the Capstone program is a significant milestone in the computer science program. And the team wants to recognize everyone who made this possible, as well as thank them for the opportunity. It's been a pleasure and an honor and a great learning experience. And finally, for anyone interested, we've left some links here to the Secure Mailboxes organization on GitHub. It hosts our API code base as well as our command line client code base. And for anyone looking to get involved, we welcome contributions in small or large from everyone. The code is and will remain to be 100% open source under the Apache 2.0 license.